In this lesson, we're learning how to solve quadratic equations by 4 different methods: graphing, factoring, using the quadratic formula, and by completing the square. So these are 4 different tools that are in your tool belt to be able to solve quadratic equations. And remember, quadratic equations have a degree of 2. So in this example here, we've got 3 terms. Here's our quadratic term, degree 2, linear term, degree 1, and our constant term, degree 0. Let's take a look at our first tool that we can use to solve quadratic equations, and that tool is graphing. So if we were to take an equation and set it equal to 0, or rearrange it so that it's equal to 0, and if we graph that equation, then the roots or x-intercepts of that graph will be the solution or solutions of our equation. So for example, here's the equation: f at x equals x squared minus x minus 1. So there's a slight typo here. We're going to change this f at x to x. So do that with me as well in your handout. So what the new question now asks is find our x value when f at x equals 1. So I want to know what's x when my y is equal to 1. So what I'm going to do is I'm going to replace that f at x with 1. So I have 1 equals x squared minus x minus 1. And then if I graph this equation right now, which I absolutely can, the solutions, or our x values to this equation, is whatever x is when y is equal to 1, or when the function equals 1. An easier way to do this, instead of looking for when the graph is going to be 1, is looking when the graph is going to be 0. So bring that 1 onto the other side, so that we have 0 on the left side. So we have 0 equals x squared minus x, and then we're going to have minus 2. Because we have negative 1 minus another 1 is going to make negative 2. So now if we graph this graph, we're going to look for when y is equal to 0, and that's going to be our solutions. So here I've graphed the equation. This is the equation y is equal to x squared minus x minus 2. That's this equation right over here. And I'm going to check, when is the function equal to 0? Well, it's equal to 0 right here, at this point here, and at this point here. And so here we know that x is equal to negative 1, and here x is equal to 2. So therefore the solutions are x is equal to negative 1 and x is equal to 2. So if you want to solve by graphing, which we're going to do a lot in grade 12, just isolate, or make sure that we have 0 on one side of the equation. It's much easier to find the solutions. Graph whatever equation is left over and check what those x-intercepts are. Whatever the x-intercepts are, that's going to be the solution for when y equals 0, and so that's going to be the solution to the equation. So let's take a look at the next technique. The next technique is completing the square. Normally we use that in order to find the maximum or minimum or vertex of a function, but here we can also use it to solve for x, because when we complete the square there's only going to be one x term. The reason why solving quadratics is harder than solving linear relations is because we've got 2 x terms and they're not like terms, so we can't bring them together. But by completing the square we're going to only have one x term. So this question gives us a function and it asks us for the x-intercepts, and we know that the x-intercepts just mean that we're plugging in y is equal to 0 or f at x is equal to 0. So we're going to start with that, and then we're going to complete the square. So we're starting with our function 4x squared plus 8x minus 3, and we're going to sub in that f at x is equal to 0. The reason why I can do that is because we're looking for the x-intercepts. So we're going to start off with 0 equals 4x squared plus 8x minus 3. So at this point you can bring the negative 3 over if you want, or you can just leave it alone and just continue completing the square. In this case I'm just going to leave it alone. So we're going to start our process by taking out our a value from our first 2 terms. Next we're going to complete the perfect square trinomial. So we're going to add something and take it away. So remember our trick, we're going to take this 2, divide it by 2 and square it. So 2 divided by 2 is 1, and 1 squared is 1. So we are going to add 1 and subtract 1, so we're really adding 0. Next we're going to kick this negative term out. We're left with 0 equals 4, x squared plus 2x plus 1. And we have 4 times our negative 1 before it leaves is going to make negative 4 minus 3. We have 0 equals 4, x plus 1 all squared minus 7. So now that we've completed the square, we can start isolating for our x value since there is only one. First thing we're going to do is we're going to move this negative 7 onto the other side. So we're going to be left with positive 7 is equal to 4x plus 1 all squared. Next, we can divide by 4. We're isolating for that x. So I'm going to divide by 4 on both sides. And I'm going to be left with 7 over 4 is equal to x plus 1 all squared. Next, we got to get rid of that square root over here. So we're going to square root both sides. Let's continue it up here. Okay. So on the left, we know how to do with radicals now. So this is equivalent to root 7 over root 4. So I'm just going to change that to root 7 over root 4 because I know I can find the root of 4. So this is why it makes sense to split this one up. I'll be left with x plus 1. So we're going to, in our next step, also bring that plus 1 onto the other side. And on the left, we're going to be left with root 7 all over square root of 4, which is 2. And then we have subtracting 1 is equal to x. Now, something's wrong with our solution because we should have two solutions, but we only have one. If I take a look here, if I were to sub in x equals 0 very quickly, I can see that my y-intercept is negative 3. And this parabola opens up, which means I should have two zeros. If you were to plot a y-intercept of negative 3 and opening up, should have two zeros. So take a look back over here. Remember that when we take a square root of something, we have to include our little plus and minus sign. So we're going to add our plus and minus sign all the way through here. I'm going to add it in the middle here. Okay, so we've got plus and minus. So here are our two zeros. Our first zero, our x1, is going to be positive root 7 over 2 minus 1. And our second is going to be negative root 7. Let me fix this one. Okay, so negative root 7 over 2 minus 1. So that's how we can solve by completing the square. If you really wanted to check, did I get this answer right? What I would do is go onto your Desmos app and pop this into Desmos, this equation here, y equals 4x squared plus 8x minus 3, and take a look at those zeros. So hover over the zeros and you should get these two solutions. Now, they're not going to give it to you in exact form like what we have. They're going to have a decimal, but if you take a look, the decimals values are the same as our solutions here. Okay, our next more traditional way of solving quadratic equations is by factoring, and we practiced this a lot in previous units. So we are given the equation x squared plus 7x plus 12, and we need to find, another quick little typo here, we need to find our x value when f at x is equal to 2. So make sure you change this to x. Okay, so here's our equation. We know we're going to sub in f at x equals 2, so I'm going to plug in a 2, and we've got x squared plus 7x plus 12. To factor, just like when we graph, it's much easier if we isolate for, or sorry, if we make sure that one of the sides is equal to 0. So we're going to bring that 2 onto the other side. We've got 0 equals x squared plus 7x plus 12 minus 2, which is going to be 10. So we have 0 equals x squared plus 7x plus 10. And now we're just going to factor this by sum and product. So we're looking for two numbers that multiply to 10 and add to 7. And those two numbers are going to be 5 and 2. So we're going to break this up into our factors. So we have x plus 5 and x plus 2. And now because we have 0 on the left-hand side, we're guessing values of x so that the entire equation would be 0. So our first value of x would be negative 5, and our second would be negative 2. So we have our x1 is equal to negative 5, and our x2 is equal to negative 2. Remember, if you have a factor that's difficult to see what the 0 is, just set our binomial equal to 0 and solve for x. So in this case, x is negative 5 and x is equal to negative 2. So those are the two solutions to this equation. So far in summary, the fastest way, it seems, to solve quadratic equations is by factoring, and that's only going to happen if our numbers are nice. And the other fast way is by graphing, but we won't always have graphing technology available to us. So you can always solve by completing the square. Another way you can always solve quadratic equations is by using the quadratic formula, which is here. So here we're given another equation. We're looking for x when f at x is equal to 5. All right, so here's our equation. We're subbing in f at x equals 5. So we've got 5 is equal to 2x squared minus 3x minus 4. So just like some of the other techniques, we need to make sure that we have one of the sides is equal to 0. So we got to bring this 5 over. We're left with 0 equals 2x squared minus 3x. I'm going to go ahead and take negative 4 minus 5 right away. I'm going to be left with negative 9. So here we have a quadratic in standard form. The leading coefficient is our a value, so that's in front of the x squared term or the quadratic term. In our linear term, our coefficient is b, so our b is negative 3, and then we have our constant term, and that's c. So just to summarize, our a is equal to 2, our b is equal to negative 3, and our c is equal to negative 9. And what we're going to do is we're going to plug that into the quadratic equation. So I've written it out once more so we don't make any mistakes. So we have x is equal to negative, and we're going to plug in our b value, which is negative 3. Then we have plus or minus the square root of our b value again is negative 3, and we're going to square that. Minus 4, our a value is 2, and our c value is negative 9, all over 2, and then our a value is also 2. So let's continue simplifying. We've got x is equal to negative 3, just going to be 3, plus or minus, and let's figure out what's under the square root. So I like to throw this entire thing into the calculator, think about what it is, just using mental math. So under the square root, what we're going to have is just the number 81. That's what that's going to simplify to. All over 2 times 2 is 4. So continuing, we have x is equal to 3 plus or minus the square root of 81 is 9 all over 4. So our two x-intercepts are x1 is equal to 3 plus 9 over 4, and our second, or not x-intercept, but solution is going to be 3 minus 9 all over 4. So continuing to simplify, we have x1 is equal to 12 over 4, which is equal to 3. And our second x-intercept is 3 minus 9, which is negative 6, all over 4, which is equal to negative 3 over 2. So now we've summarized 4 different ways that you can solve quadratics. What we're going to do is we're going to apply them to some application problems. And remember, it doesn't matter what method you choose. You can use any of them. You're always looking for the method that's going to be most time efficient. So this first problem is a tricky one. So it says Chris and John are cutting a rectangular lawn that's 30 meters by 40 meters. Chris starts by mowing strips of equal width around its perimeter, while John starts cutting a rectangular patch in the middle. How wide a strip should Chris cut so that they share the work equally? So they want to make sure that the two areas that they mow are exactly the same so that it's fair. So let's first start off by drawing a picture. So we have a rectangular lawn. We know its dimensions. We know its width is 30 meters and its length is 40 meters. We know that Chris is mowing on the outside and John is mowing on the inside. So in the end, their areas are going to look something like this, where this is where, in the middle is where John is going to be mowing his lawn. And on the outside, this is where Chris is going to be mowing his lawn. What we don't know is how wide a strip Chris should cut so that they share the work evenly. So what we don't know is this length right here and this length right here. And it's going to be equal, because if you read through the question carefully, it says he mows strips of equal width around the perimeter. So what we don't know, let's call x. So I'm going to call this width x. So this is x and this is x here. Notice that in the question, it does not ask us for the maximum area or the minimum time. So we know we're not finding a vertex here. We're just solving an equation. But what we don't have is an equation. But we do know that John's area has to match Chris's area. So let's figure out an equation for John's area because that looks a little bit easier. So John's area is just a rectangle. So we're going to work on John's area. We know his area, so area for John is just going to be length times width. But his length is not going to be 40 and his width not going to be 30. It's going to be just this bit here. So if this is x, we also know that this part here is x. So the length that he's actually going to be cutting is 40, but take away an x here and take away an x here. So it's going to be 40 minus x, which is going to be minus 2x. So his new length is going to be 40 and take away 2 of the x lengths. Now take a look at his width. His width was originally 30, but that's not what John's going to mow because we have a width here of x and we have a width here also of x. I'm going to add that in. That we have to subtract from 30. So one more time, the entire width is 30. We're going to take away an x, we're going to take away another x, and that's going to be the width that John is going to mow. So we still know what x is, that's okay. So we have our width is going to be 30 minus 2x. So now let's simplify this, or let's expand this. We're going to FOIL and simplify. So we have area for John is going to be 40 times 30, and that's going to be 1200, minus 80x minus 60x plus 4x squared. So if we simplify that, I'm going to bring the 4x squared first. We have area for John is going to be 4x squared. If I simplify this, negative 80 minus 60, I'll get a minus 140x plus 1200. So we have John's area now. So now let's figure out Chris's area because we know it has to be equal to John's. So Chris's area almost looks like a picture frame. So we did questions like this maybe in grade 9 where it said the entire frame has a certain area and the picture has a certain area. What's the area of just the outside frame? And so it's a similar question. So we have the original length and width, or our original area is going to be 40 times 30. To find Chris's area, we're just going to take out John's area. So we're going to take the total area, take out John's area, and we're going to be left with this strip around here. So Chris's area, we are going to take, so area for Chris, we're going to take the entire area. So the entire area is going to be, so I'm going to put area total, and then we're going to take away John's area. So Chris's area is going to be, the total area is going to be 30 times 40, and we're going to take away John's area. And we know John's area is just this right here. So I'm going to rewrite that out. So we're going to subtract 4x squared minus 140x plus 1200. Okay, so we have Chris's area is going to be 30 times 40, that's 1200. And we are going to make sure that before we take away that negative that we've distributed inside this trinomial. So we have minus 4x plus 140x minus 1200. So the lovely thing here is these two 1200s are going to cancel out because 1200 minus 1200 is 0. So we have Chris's area is going to be negative 4x squared plus 140x. So now we have two equations. Go back to the question and remember the original question said how wide should the strip be? So that means what is our x value so that they share the work equally. That means that we are going to make sure that these two areas are exactly the same. So our final equation is going to come from the rule that John's area has to equal Chris's area according to this question. So I'm going to take John's area. We know that's 4x squared minus 140x plus 1200. Subtract, is equal to, I apologize, so we have John's area equals Chris's area, so here's John's area is equal to Chris's area, so we have negative 4x squared plus 140x, and honestly the hard part is done. Now all we're doing is we're solving for x. So make sure that bring everything onto one side, and then choose whatever method you want to solve. So I really like dealing with positive leading coefficients, so what I'm going to do is I'm going to bring these terms over onto this side, but you can really bring bring it to whatever side you like. So we have 4x squared. When I bring this negative 4x onto the other side, we're going to have plus 4x squared. Then I have negative 140x. When I bring this guy onto the other side, I'm also going to have another negative 140x. And then I have a plus 1200 left over. And of course, that side is equal to 0. If I simplify, what I'm actually going to just do is flip these two sides. So I'm going to have 0, start with 0 equals, and then I have 4x squared, and I have these two terms. So 4x squared plus 4x squared, that's going to be 8x squared. Negative 140 minus 140 is going to be negative 280x. And then I have plus 1200. So now I can choose whatever I want to solve this thing. So I have the left side is equal to 0. I could use a quadratic formula. I could complete the square and solve for x. In this case, I have really nice whole numbers, and I can see that 8 is divisible by all of these coefficients. So I'm going to try factoring, because factoring is a lot faster if we can do it quickly. So I'm just taking out the 8. So what I did is I common factored out an 8, and I'll be left with x squared minus 35x plus 150. So now what I'm going to do is I'm going to use sum and product just for this trinomial here, and we'll leave 8 on the outside. So I'm looking for two numbers that multiply to 150 and add to negative 35. And that's going to be 30 and 5, and both of them have to be negative. So when I factor this, I'm going to have 0 is equal to 8, x minus 30, and x minus 5. All right, so now we can solve this thing. So now that my left side is equal to 0 and I've factored, I can guess my values for x. So I know if x is equal to 30, the entire thing will be 0, and if x is equal to 5, the entire thing will be 0. So my x1 is 30, and my x2 is equal to 5. So in the previous examples where we didn't have a real-world context, we would be done. However, in this case, we have real-world limitations. So I can't go and say, okay, it means x can be 30 and x can be 5. We have to check to make sure that these numbers make sense in our question. And also, just to make it really clear, if you decided to use the quadratic formula either here or here, you would get the exact same answers as us. So let's go back up to our picture and see if x is equal to 30 and x is equal to 5 makes sense. So let's come back up here. So one of our solutions was x is equal to 5. I'm just going to write it up here. And the other one was x is equal to 30. The question is, can x equal 5? Well, if x is equal to 5, that means there's a 5 here and there's a 5 here that's going to sum to 10. That means that John's width now is 20, because 20 plus 5 is 30. Taking a look at our length, original length was 40. If this is 5, if this is 5, that means that John's length is now 30. So we have an area of 20 times 30. That seems to make sense. How about an x value of 30? So taking a look here, if this was 30 and this was 30, how could that be if the entire width is supposed to be 30? That means that the new width is negative 30? That doesn't make any sense. So in this case, this solution doesn't make sense in this specific example, which means that we're going to throw this one out, and our final conclusion is the only way that they can do an equal amount of work is if the width of that strip is 5 meters. So therefore, the width of the strip must be 5 meters. Let's try the next tricky example. So it says Satil makes a journey of 430 kilometers, traveling 160 kilometers by bus and 270 kilometers by car. So he's going 2 different speeds to make this total. If the car averages 10 kilometers per hour faster than the bus and the whole journey takes 5 hours, what is the speed of the car? So this might look really overwhelming to you. What I'm going to recommend is to make a chart, and here's what I mean. So in this question, we're given speed, time, and distance, and we know that speed, time, and distance are all related to each other. So you can use the triangle if it helps you. We know the total distance someone travels is determined by its speed multiplied by its time. So if you're familiar with the triangle, we can see that d is equal to s times t. Our time is equal to d over s, and our speed is equal to d over t. So I'm going to organize all the information we have. I'm going to write the distance in this column, our speed, and our time. Okay. So what I'm going to put in my left-hand column are the two modes of transportation that I have. So I have information by when we went by bus and the journey by car. And then we have some totals. So I'm going to make a total column. So now I'm just going to read the information and fill it in. So you have it in front of you. I'm going to read it out loud. It says Satil makes a journey of 430 kilometers. So that means his total kilometers is 430. So that's going to go in the distance column under total. So total kilometers is 430. Okay, so he traveled 160 by bus. So in the bus column for distance, I'm putting 160 kilometers. And by car, he travels 270 kilometers. So next it says, if the car averages 10 kilometers per hour faster than the bus. So the car is going 10 kilometers faster than the bus. Problem is we don't know how fast the bus is going. So now we need a variable. So I'm going to use B for the speed of the bus. And if the car is going 10 kilometers faster, that means the speed of the car is going to be the bus speed plus 10. So let's write a little note on the side that we know that our B is going to represent the speed of the bus in kilometers per hour. Okay, finally, one last piece of information. It says the whole journey takes 5 hours. So that means that the total times 5 hours, which means I have to put a 5 right here. The total hours is 5. So now I'm sort of stuck because I don't know what the speeds are supposed to add to. These two numbers add to 430, so that doesn't really help me. What I need to find is my time, and that's when our relationship between speed, distance, time is going to come in handy. So our time on the bus is going to come out to our distance divided by our speed. And our time in the car is also going to be distance divided by our speed. So our time on the bus is going to be distance, which is 160. 160. And divided by our speed, which is B. And our time in the car is going to be the car's distance, which is 270. And divided by its speed. So B plus 10. So if we have an expression for the time on the bus and we have an expression for the time in the car, they should both add up to 5, and that's where our equation is going to come from. So it's going to come from this row right here. We've already used a relationship horizontally. Our only last one is to pull from it vertically. So I know that my equation 160 over B plus 270 all over B plus 10 has to equal 5. So if you go back to the question, it just asks for what is the speed of the car. So I have the speed of the bus. Well, I'm going to find the speed of the bus, B. Once I find that, we know how to find the speed of the car. We're just going to add 10 to it. So the question is, how do I simplify this? Well, we did an entire unit on this. How do we add rational expressions? First, we have to make sure that the denominator is the same. So our greatest common factor, not our greatest common factor, our lowest common denominator, so our lowest common denominator has to be B and B plus 10. So I'm going to multiply this fraction by B, making sure we put brackets around here, and this fraction should get multiplied by B plus 10 and B plus 10. So in the numerator, we have 160 times B plus 10 all over B times B plus 10 plus 270 times B all over B plus 10, and that's all equal to 5. So let's distribute this, and we're going to add those numerators. Don't multiply the numerators, make sure we add them. So our big denominator is going to be B plus 10. There's no need to expand that because it's all factored. We're going to expand this guy here. So we have 160B plus 1,600 plus 270B is equal to 5. We're going to keep on simplifying. So if we add these two like terms here, we're left with 430B plus 1,600 all over b times b plus 10 is going to equal 5. And now we're kind of stuck because we need to solve for b's, but there's b's all over the place. So what we need to do is get these b's from the denominator to the numerator. We need to get rid of this fraction. And so to do that, I'm going to get rid of this divided by b times b plus 10 by multiplying by b times b plus 10. So I'm going to multiply it on the left side. I'm going to multiply by b times b plus 10. I'm going to multiply this side also by b times b plus 10. Then what's going to happen is b times b plus 10 divided by b plus b plus 10, b times b plus 10 is going to be 1. And everything's factored on the top because we have this factor times this factor here. So on the left, we're left with 430b plus 1600 is equal to 5b plus 10. And now what we have is everything on the same level. We've got no more fractions left. We know we can expand this, and what we're going to do is expand, collect like terms, and solve. So I'm going to bring everything over here onto the other side. So this 430 goes onto the other side, same with the 1600. And the left side will have 0 equals. At the same time, I'm also going to expand this 5b into this binomial. So I have 5b squared plus, then I have minus 50b, and then I'm bringing that 430b over, so I have minus 430b minus 1600. Before we keep going, this minus 50 should be a plus 50. And this 160 should be a 1600. Okay, so I think we've caught all the mistakes here. So we've got 0 equals, and I'm going to collect these two terms here, and I've got 5b squared minus 380b minus 1600. So the hard part is done now. We've taken all the information, we've created an equation, we know it has to equal 0, so all we have left to do is solve for our b, and we know our b is the speed of the bus. Once we have the speed of the bus, we can find the speed of the car, and then we're going to be done. So solve this however you like. If you want to factor out this 5 and try factoring, go for it. I'm going to use the quadratic formula just because that 1600 scares me, even if I were to divide it by 5. So I'm going to try the quadratic formula, use whatever it is that you want, come back to the video and check your answer. Okay, so here's my worked out solution. Your two zeros should be should be 80 and negative 40. If you didn't get that, go through and check your solution again. Compare it to my solution. Also, as I note, we don't even have an x in this equation. Why do I have x here? So what I'm going to do is I'm going to switch this. Sometimes this will happen. And we really have, this is b, this is b, this is b. And this is nice and confusing because we've got two different b's. We have a b for the bus speed and we have a b here. Lots of b's, but we know what each b means. So in the end, we have our b1 is equal to 80 and our b2 is equal to negative 40. In this case, can b be negative? Sometimes yes, sometimes no. It depends on what b is. B is the speed of a bus. Can the speed be negative? No, definitely not. Which means that in this case, this solution doesn't make any sense. And so this is the only solution that makes sense, that the speed of the bus must be 80 kilometers per hour. So let's use that information and finish up that problem. So we're going to bring it up to the top. Again, it says, what is the speed of the car? So if the speed of the bus is 80 kilometers an hour, then the speed of the car is just going to be 80 plus 10, which is going to be 90. Oops, 90. Therefore, the speed of the car is 90 kilometers per hour. And there's not two solutions for this, there's just the one. Okay, we're going to try one last example. This example says, when a ball is thrown upward, its height in h in meters is given by the function, it's given us there, where t is the number of seconds after it's thrown. For what length of time is the ball higher than 16.2 meters? So let's draw a quick graph just to make sure that this makes sense. So this is a parabola because it's a quadratic equation, and its leading coefficient negative 4.9 t squared, so negative 4.9 is the leading coefficient, is negative, and so this parabola opens down. The ball was thrown, so we're assuming it wasn't thrown exactly from the ground. And it's asking how for how long is it above a certain height. So that means that that can't be the maximum. That means it's probably somewhere here. So that height that we're given is 16.2 meters. 0.2 meters. So this is our height in meters. This is our time in seconds. So what it is asking is how long is it above that height. So that means we need to find this t, that's going to be our t1. We should have a second t, that's going to be our t2. And we need to find the length of time between t1 and t2. So once we have our two t's, we're just going to subtract them. Figure out how long is the ball actually above that height. So this is an easier question than what we've been dealing with, only because we're given the equation. We don't have to make it ourselves. So quickly write out the equation. Here it is. And sub in our height that we're given. Our height is 16.2 meters. So we're going to sub that in for our height. So we have 16.2 meters is equal to 1.5 plus 19.6 t minus 4.9 t squared. And now all we have to do is solve this thing. So we know in all the methods that we use, we always want to make sure one side is equal to 0. So I'm going to bring that 16.2 over to the other side. I'm also going to rearrange it so I have it in standard form so that my quadratic term is first. So I'm going to put negative 4.9 t squared. Then I have plus 19.6 t plus 1.5. And let's take away that 16.2 that we brought to this side. When we simplify these middle terms, not the middle terms, when we simplify these outside terms over here, we have negative 4.9 t squared plus 19.6 t. Then we have minus 14.7. So now all we have to do is solve this equation. I definitely don't want to factor this because it has a whole lot of decimals. I think the fastest way to do this would be the quadratic formula. So that's what I'm going to do. So try the quadratic formula and check back in once you have your answer. So once you finish the quadratic formula, you should have something that looks like this. We have negative 19.6 plus or minus the square root of 96.04 all over negative 9.8. So we have two solutions. We should have two positive solutions because taking a look at our picture here, we should have a positive t as well as a positive t2. So again, I made the same mistake that I made last time, which is that we don't have an x value with a t value. So I'm going to write t and t over this. So let's solve for our first t value. Our first t value is going to be negative 19.6 plus square root of 96.04 all over negative 9.8. And that's going to be 1. It works out to such a lovely number. Maybe our t2 is going to work out to the same. So we have t2 is equal to negative 19.6 minus square root of 96.04 all over negative 9.8. And that's going to equal 3. So this was factorable. Okay, so we have our two t's. Our first t is 1. So I'm going to add it in here, 1 second. And our second t is 3 seconds. So the question is, for how long is it above this, this height here? And that answer is, well, it's above that between second 1 and second 3. So that means it's up there for 2 seconds. So our change in t is going to be our t2 minus our t1. And our change in t is going to be 3 minus 1, which is going to be 2. So therefore, the ball would be above this height for 2 seconds.